Hi and welcome to this junior cycle higher level maths video where we're looking at applied arithmetic and specifically interest. So in this video we're going to cover what is interest, we're going to look at simple interest, compound interest, calculating interest, and then also working with tax on interest, which is called DIRT, D-I-R-T, deposit interest retention tax. At the start of this video, for the first 11 minutes, I'm just going to go through kind of a little bit about interest, interest rates, where you can borrow and so on. This is more background information and probably more beneficial for anybody who has not studied business. But if you want to skip straight to the 11th minute, we will get into what we actually need for the junior cycle exam. So, what is interest? So if you invest money in a building society or a bank savings account, the building society or bank pays you interest. So invest means you put money in. Think of invest. So you put the money in. If you borrow money, so if you take the money out, so if you don't have money and you borrow it, so things that you might borrow money for might be you might buy a car and you don't have all that money, so you borrow the money from the bank and you pay them back week or monthly. Maybe you want to buy a house and you don't have that kind of money sitting around, so you borrow that. So if you borrow money, you pay the interest to the bank. So interest is basically the cost of money. So if you put your money into a bank, the bank uses that while you're not using it, and they get interest from people, so in turn they give you a little bit. If you borrow money, because you're holding someone else's money, you have to pay them for that. So that's the best way to think of interest. It is the cost of money. So the interest is worked out as a percentage of the amount you lend or you borrow. So think of your investing, you putting money into the bank as a loan to the bank. So you're lending them your money. And what they do is they pool everyone's money together, and then they can use that to give out to other people who need money right now. So it just means there's a very efficient use of money in society. So where can you save? So you could save in credit union, you could save in the post office, building society. So building societies were initially set up as groups of people who kind of pooled their money together to build, as the name suggests. They built generally houses. UBS was for education, so educational-based professions use that. Building societies are pretty much act like banks. There's very little difference now, but they're still, I suppose, historically thought of as building societies. We have our banks, so we have some of them still in Ireland, some of them leaving. But I suppose the question is, do you save under your mattress? Do you have a piggy bank? Do you put your cash in your sock drawer? And I suppose where is best to save? And the problem is, if you put your money under your mattress or into your piggy bank or in your sock drawer, you are not getting any interest. So everywhere else, anywhere that you put in your money is going to give you some form of interest. So here are some examples of interest rates. So if you wanted to save, there are a few different saving accounts available. This is just from a comparison website. They give us what is called the AER. Now we'll talk about that a bit more, but what it stands for is the annual, I say effective rate, it's the annual equivalent rate either. And it basically means even though you might be getting your interest annually, what would it be if you were to get it annually? So it's a legal requirement to make sure we can compare everything. I suppose what I want you to take in on this slide is to see how small. We get 0.9% from the bottom permanent TSB. Now you have to be a regular saver, so you have to be putting money in all the time. Thinking of that percentage, that means in a year, if you were to save €100, they'll give you 90 cents interest. And that's not a lot. But the best interest you could get is €1.25. So I suppose when you save it, you're not going to get a huge amount of interest. The interest basically will relate to how risky something is. So if you want to make lots and lots of money, you have to take a gamble. So you would have to invest in riskier options. But most people will save in a normal savings account with a bank or building society. Some banks don't even give interest. So here are some of the lowest ones. So you could get that top one gives you 1 cent for every €100 each year. And then the bottom one gives you no money. And I suppose it really depends on what you want. You get a lot more flexibility with lower interest rates. The more interest rate they're going to give you, the more tied up your money is, which basically means you would have to save a certain amount. You're giving them more money and you're giving them to quite regular. So if you're somebody who might just save on your birthday or Christmas or whenever somebody comes to give you money, that you're not going to be what the bank wants. The bank wants people to be giving them in money very regularly. So good news is, if you are a junior saver, so if you were a child, so when you're younger, you can get much better interest rates. Now I say much better. It's double the interest rate for one we saw, so we will get 2.5%. So children get a lot more, but I think the idea there is that they're not taking out their money the same way, so they're given a slightly better interest rate. Now, you can also borrow money, so you have to be over 18 to do this, but you would borrow it in most of the same places, but we'll talk about some specialty places that exist as well. So credit unions, building societies, banks, post office. But take a look at the APR. So APR, we use that when we're talking about loans. It stands for annual percentage rate. It is kind of the same thing as AER. We use just two different acronyms for it. But look at the difference. The lowest interest rate I can pay on a loan in this particular comparison website on this particular day was 8.4%. So what that means is, when I was saving, the most they would give me was €1.25 on every €100 per year. If I borrow that €100, I have to pay them €8.40. So that's how I suppose banks make money. They charge more than they give out. So when we're talking about loans, we have different percentages depending on how long you're going to need the money for. So these are what we would consider maybe medium term, maybe 5 years. All of these show I borrowed €5,000, and they have included, very helpfully, a repayment amount. So you can see here that I end up paying an extra like €648.76 over 5 years. So there is a question about, do you really need loans? But the thing is, yes, loans exist for a very specific reason, and 5-year loan might be something like car or even education. Somebody going to college would need to cover that. Here's the higher end of the spectrum. We have 14.3. So you would end up, for every €100 you borrowed, you have to pay them €14.30. So that's a home improvement loan. So again, if you take a look at the total repayment, we borrowed 5,000. We pay them over €1,000 back, nearly 1,100. So I suppose understand that for loans, we pay much more interest than we will ever receive from our investments. If you look at very short-term borrowing, so that would be things like credit cards. Credit cards charge a much higher rate because you're less likely to hold on to that money for a full year. So let's take a look at some typical APR, so again, annual percentage rates. So we have the lowest one about 13.8%. So that means for every €100 you borrow, you're paying back €13.80. But they get big very quickly. So you can see here, 35%. So you borrow €100 over the year, you pay them back €135. So an extra €35. So just, I suppose, be very aware in the future when you're working with credit cards. But if you're kind of seeing random interest rates, do they have to be small? Do they have to be big? It really depends on what the product is. So if you can't get a loan from a bank or a building society or credit union, one option is money lenders or payday loans. You might have seen ads on the telly. This one is a Migo loan. Well, look at this. So 49.9% APR, which is fixed, which means you borrow €100, you pay back €149.90 at the end of the year. So you're paying back so much money. Again, this is quite short. They tend to be what we say payday loans, people get them to see them until their next payday. So they tend to be quite short. And because of that, if somebody is only borrowing for a week or two, they're only paying back a couple of euros, so they don't see that percentage in the same way. So that's something to be aware of. They do come with a warning now. You can see it there on the screen. It says, warning, this is a high cost loan. The people who will go to, I suppose, money lenders, things like Amigo loans, people who cannot get a loan from a bank or a building society. And that's usually because maybe they're not earning enough, or maybe they had a loan in the past they didn't pay back. So there is a market for those. They've improved hugely, but still not great. So there's a little bit at the bottom there. It said borrowing 2,500 over 36 months means you end up paying 4,392 back. So you nearly double what you pay back over 36 months. That's 3 years. So there's a little bit, if you want to pause this to read, this is from the journal from a few years ago when they launched. Ireland didn't have many money lenders like these. There was a lot in the UK. They were charging a huge amount about 10, 15 years ago. Now they are regulated, so they cannot charge as much. So there's our Amigo loan there. The 49.9%, if you pay back 5,000 euro, if you borrow 5,000 euro, you're paying back 8,782 euro and 20 cents. That is a lot to pay back. Okay, so let's talk about types of interest. So imagine you pay 100 euro into your bank account, and they tell you to leave the money in the bank, and they will add to it. So they're going to give you 10% every year. Wow. And that's much higher if you were watching than what we will get now. But if you were, just to make the numbers nice, to get 10% each year, that's fantastic. But the question is, how do we apply it? So that 10% is interest, and it's the money that you get for letting the bank use your money when you don't have it. But how they apply that 10% is different depending on whether we're dealing with simple interest or compound interest. So let me show you with an example the difference. Here's Anna. Anna is going to show us simple interest. So Anna has 10% simple interest on her 200 euro, and each year she'll get 10% of her 200 euro. So she's going to get 20 euro for each year she leaves her money there. So here's what the first 5 years look like. So year 1, she has 200. Then she gets 20 euros, so she's 220 in year 1. And then year 2, 240, year 3, year 4, and so on. And she ends up with 300 euro, which is quite nice. So she gets 10% every year. So she gets 10% of that 200 every single year. Now, the reason this is called simple interest is because the interest is calculated at the start, so on the initial principles. That's what we call the money that we invest. So the initial principal, and the same amount is added on every year. But is that really fair? Because in year 1, she has 220 euro. So is it fair she only gets 20 euro? So let's explore compound interest with Betty. So Betty also has 200 euro and is also getting 10% interest. However, her interest is compound interest, which means that not only does she get 10% of her 200, her initial principal, she's also going to get some percentage of interest on her interest. So this is how it looks. She starts off with 200 euro, just like Anna. She then gets 10% of 200, which is 20, and we get 220 euro. Okay. We then, for year 2, she doesn't get 10% of 200. She actually gets 10% of 220, which means she gets 22 euro. So she ends up with 242 euro in year 2, and so on. And look what happens by the year 5. So she has 322 euro and 10 cents. Now, think about that compared to poor Anna, who was getting interest. So Betty, ends up with €22.10 more than Anna did. So the simple interest is something that I suppose we don't really see out in the real world. It's more likely that we have compounded interest. Compound means to add together, and the reason it's called compound interest is because you're getting interest on the interest. Your interest is compounded. So you're making lots of extra money because you're getting interest on the interest as well. So on page 30 of your log tables, we have a formula that we're going to use to help us calculate this. You don't have to use the formula, and sometimes we can't use the formula, but it is a handy little one to have. You may not find that page very easily. However, if you go to your log tables and go to the contents page, it's under financial mathematics. It's called a compound interest formula, and it is F equals P bracket 1 plus I to the power of t. So F stands for final value, P stands for principals, that's the amount that you invest, 1 plus I. Now up at the top it tells us that, let me get my highlighter so you can see where I'm looking because there's quite a lot of writing going on. I is the annual rate expressed as a decimal. So for example 8% would be 0.08. So that is I, and then T is the time in years. So that's our little formula. It's super handy. You may not have met it in business because often those questions are a little bit complicated with money going in and out of accounts. For us in maths, they tend to be a little simpler, a little bit more straightforward, meaning we can use this formula, but you're welcome to work this through as a table, and we'll see some examples of those as well. So let me show you how to use this formula. So Kathy invests €300 with compound interest of 3%. So she is investing for 5 years. So this is our formula. So let's start with this. So F is what we want. P is the amount she invested. So that's 300. I is our interest rate, which is 3%, but we write that as a decimal. To help you with that, divide by 100. We then have T, which is 5 years, and then we plug into our formula. F equals 300. 1 plus 0.08 to the power of 5. Now, you can put that straight into your calculator. Use it exactly, or write it in exactly as we have it there on the screen. You have an x to a power button, which basically allows you to put in any power you want. So you can put in your power 5. And when you do that, we end up with €440.798423. This is cent, so we're going to round it after 2 decimal places. The next number after the 2 decimal places is 8, which means we round up. So we get 440.80. So that's how much Kathy will have in her account in 5 years' time. So rather than working it through and finding a percentage each year, which we can do, and that's absolutely fine, this is a much more efficient way to work. So let's take a look at the 2020 Junior Cycle sample paper question. Which is about Millie, and she has €3,000 in a special savings account. It has an interest rate of 2.5% per year. Let's get our highlighter. So we have 2.5% per year for 4 years compounded annually. She does not put in any money and she does not take out any money. Find the total amount in her account after 4 years, correct to the nearest cent. So this is a perfect question to use our formula with because there's no money in, no money out. In that case, we will have to do a table and work it year on year. So let's take a look at what we have. F, that's the future value. That's what we're looking for. P is the principal, so how much she saved, so that's 3,000. I is our interest rate, which is 2.5%, but we need that as a decimal. So we're going to divide that by 100. So getting your percentage to decimal, divide by 100, 0.025. Just be really careful with that process. And then T is 4 years. So F is equal to P, which is 3000, times 1 plus 0.025, all to the power of 4. So again, this can go straight into our calculators, 1 plus 0.025, and then all to the power of 4. We get 3311.438672. It's money, so we always want to round it to the nearest cent, unless we're told otherwise, i.e. to the nearest euro. And we get 3,311 and 48 is the next number, so it rounds up 44. So they've asked us for the final value. If we were to be asked about how much interest did Millie get, we will be able to subtract the 3,000 from our final answer. Then we can see then she would have got €311.44 as interest over the 4 years. So let's look at a question from the 2019 Junior Certificate paper. Katie got a credit card bill 3 months ago for €420 and the interest rate is 2% per month, compounded monthly. She has not paid off any of the bill. Work out what her bill is now. Give your answer to the correct, or answer in euro correct to the nearest cent. Now, we are absolutely fine to use this formula again, even though it says annual, as long as our interest rate and time match, we're fine. So our interest rate is 2% per month, and we have 3 months, and then it was $420 to begin with. So this formula is compound interest on not just savings, but also borrowing. So credit card is a type of borrowing. We're trying to work out how much will she owe now. We know that initially she owed €420. We know the interest rate is 2% as a decimal at 0.02, and the time is 3 months. So F is equal to P bracket 1 plus I to the power of T. So F is equal to 420, 1 plus 0.02 to the power of 3. We then go straight to our calculator, 420, 1.02 all to the power of 3, and we get 445.70736. That gives us €445.71. So lovely, straightforward little formula. And again, not one you need to know because it's on page 30 of our log tables. So this is a Junior Cert Ordinary Level Questions from the 2014 paper, and it's just to show you how we might deal with tax. So Dermot has €5,000 and would like to invest it for 2 years. There's a special savings account offering 4% as long as the money remains for 2 years. Find the interest he would earn in the first year. So there's no need to use the formula, you can, but we basically want to find the interest, so 4% of 5,000. So you can use decimal here, 0.04. You can use 4%, whatever you prefer. I'm going to use percentage, so 4% multiplied by 5,000. Just use your percentage button on your calculator, and we get €200. So then we're told that there's tax. So tax of 33% will be deducted. So that word there means subtracted from. So it means it's taken before you get it. So we think of tax in a lot of cases as deducted. It's not something you go in and pay. It's something that's taken before you get your money. So 33% of that interest rate will be taken away before he moves forward into the next year. So we need to find 33% of €200. Again, you can use whatever method you want here. If you want to use decimal, I've done a full video on percentages. I'll link to it in the description below if you want to revise going back over basics of percentages. So now we're kind of some way near figuring out how much he actually has in his account at the end of year 1. Part 3 then asks that. So how much does he have at the start of the second year, which is the same as the end of the first year? So we have €5,000 plus the interest of 200 but then he had to pay €66 in tax. So actually he didn't get that whole 200, he only got €134 of it. Oh, I lost one of my zeros, so that's 5,000. So he has 5,134 at the start of the second year. Give the total amount of Dermot's investment at the end of the second year if the tax is deducted from the interest. So this we now have to put it all together. So first thing that we need to do is we need to find the interest. So we need to figure out 4% of 5,134. So that's going to be 5% multiplied by 5,130, 4% of 5,134. Again, if you want to put that as decimal, that's perfect. And we end up with €205.36. And that's how much interest he gets before we tax it. So then we have to find 33% of €205.36, which gives us 67.77, so it should be 7688. We'll cut it. Look at the 8. This rounds up to 7. Okay, and then that's the tax. So then we have the amount he started with, which was 5,134, plus his interest, 205.36, take away his tax, 67.77, and that goes into the calculator. And when we put that into the calculator, we end up with €5,271.59. So this is an example of where that formula we had from our log tables wouldn't be of any use, because we need to work through this year by year in order to find the interest and in turn find the tax. Now let's take a look at a higher level version with tax. So this is from the 2014 sample paper, and we're actually back to Dermot and his €5,000, but this time we have a special savings account with a rate of 3% and tax of 41%. What they tell us is there's 3% is only for the first year, and then there's a higher rate for the second year. So how much will the investment be worth at the end of year 1 after tax is deducted? So in the ordinary level question, they kind of stepped us through this. For us, at higher level, we need to be able to work this. So we get 3% of €5,000. And when we do that, we get 150. But he doesn't get to keep all that because he loses 41% of that 150 to tax. So that is 61.50. So we can deal with that there. So 150 take away 61.50 gives us that interest after tax has been deducted. So the actual interest he gets to keep, so that's €88.50. So we have €5,000 plus €88.50. Now you're welcome to add the 150 and take away the 61.50. That's absolutely fine, kind of the way we did it in the last question. But we get either way €5,088.50. So the part B is really where the challenge starts. So Dermot calculates that after tax has been deducted, his investment will be worth €5,223.60 at the end of the second year. Calculate the rate of interest for his second year. Give your answer as a percentage correct to 1 decimal place. Now, this will be, I suppose, slightly straightforward if the tax wasn't involved, but tax is involved. So I suppose we need to be able to do what we did in part A, but do it backwards. So the first thing to note is the investment was worth €5,088.50 at the end of year 1. So I had €5,088.50 multiplied by some percentage, and then that percentage gave me an answer, and then I got 41% of the answer, and then I took it away. So there's quite a lot going on here that I can't do. But if we think about the end result and working backwards, we start instead with 5,223.60. So if I subtract the amount we had at the start of the year, that will give me how much interest was actually added on. So that's a good starting point. So 508,850. So that left €135.10 as interest after tax. So tax is already gone from there. Okay, now I know the tax was the same, so that was 41%. So if I had 100% and I took away 41%, what would I be left with? And the answer is you'd be left with 59%. So we have €135.10. That is worth 59%. And in order to know the actual interest amount, we need to find 100%. Now I go through this in a lot more detail in the VAT video, again it's linked below, and a little bit in our percentages video. So I'm going to use my shortcut, which is I want 100%, so I divide 135.10 by 59%, or 0.59 if you prefer, and we end up with €228.98, and this was the amount of interest. So forget about the tax, so just the interest. So if we started with this amount and we get that much interest, basically what we're trying to do is to make a percentage. So step 1 of making a percentage is make a fraction. So I'm going to make a fraction of 228.98 over the original amount, which is €5,088.50, and let's work that out as a percentage. So let's turn this into a percentage. So that's 0.8850 is my principal. Okay. So step 1 is to make a fraction. So 228.98 all over €5,088.50. To then make it a percentage, you multiply by 100 or 100 over 1. Again, I've gone through this in more detail in the percentages video, and you can do 100 over 1 if you want, and I get 4.4995087. We'll always get something a bit kind of funny here, or generally we will, because we've probably had to round it to get it to 2 decimal places. So they've asked this correct to 1 decimal place, which means I have to cut it here. The next number is 9, so my final answer is 4.5%. So just, I suppose, be aware that if we have to find a percentage and take it away, we're also able to use the idea of, well, what percentage would that leave me? And we can work backwards, and then it turned into a very straightforward little just find the percentage question.